Hello and good day. Happy kind of Friday, Algebra. Today we're talking about CO12, which is the third of 5 rules that we're going to be learning about dealing with exponent expressions. And this one is very specific. This one deals specifically when you've got a power of 0, okay? A power of 0, which is why for our rule here, I don't even include the exponent, right? Because this rule only applies when the exponent is 0, okay? Does anybody know what happens when you have a 0 power? Christopher? The answer is 1. That's all there is to it, okay? In a nutshell, the coefficient in this case is actually what stays the same, and we'll talk about why that is in just a little bit here, okay? The coefficient doesn't change, and the base becomes a 1. Okay, the base becomes a 1. So the rule, in a nutshell, is any base to the 0 power is 1. And I'm going to underline base because this rule is deceivingly easy. Okay, it seems on the surface to be very, very simple, but where folks get tripped up is if they don't kind of focus on the fact that the base becomes a 1 and any coefficient gets left alone. Okay, let's talk about why this is. Before we go any further, let's talk about why. Okay, let's take the expression. I'm going to start with this property of division here. Let's take the expression n cubed divided by n cubed. Okay. Based in algebra, we talked about this yesterday too. What do we know about anything divided by itself? It's 1, right? No matter what n is, you know that this expression, n cubed over n cubed, will equal 1 because it's something divided by itself, right? So we can use algebra to answer that. N cubed over n cubed equals 1. Okay? If we take that same expression, n cubed over n cubed, and we apply the dividing by the same base rule, which is what we learned yesterday, what would this expression equal? Applying that dividing by the same base rule, what we just did, CO11, what would n cubed divided by n cubed equal? Kylie? N to the 0 power, right? Because the base stays the same, so we still have an n. Powers are subtracted. We have no coefficients to worry about, so that would become n to the 0 power. Everyone with me so far? Yep. Okay. Have you all heard of the transitive property? This is a geometry thing. You'll use the transitive property a lot, but basically what the transitive property says is that if A equals B, whatever A and B are, if those two things are equal, and A equals C, what do we know about B and C? They have to be the same, right? If two things, A, equal two different things, then B has to equal C. Did you follow that logic? Yeah. Right? If the same thing equals two different things, those two things also have to be equal. Right? To put this in another example, if we write 5 to be equal to 3 plus 2, and we write 5 to also equal 4 plus 1, that means that 3 plus 2 equals 4 plus 1, right? Right? Any argument there? No. Okay. So take a look at what we have here. We have n cubed over n cubed equals 1. That's our A. We have n cubed over n cubed, the same expression, equaling n to the 0. What does that tell us about n to the 0 and 1? They have to be the same, right? If A equals B and A equals C, then B has to equal C. And because n is a variable, n can equal anything, that means that any value, any base to the 0 power has to be 1. Whew. Remember I said this rule was deceivingly easy? Okay? The math behind it takes a little bit of thought. Did I lose anybody here? Yeah, Will, where did I lose you? All of it? Do you understand how anything divided by itself equals 1? So you're not confused on all of it. Do you understand that n cubed over n cubed equals n to the 0? Okay, so you're not confused on all of it. Basically, it seems like where you're getting lost is right here, right? That transitive property, okay? What this is basically saying, and what I have up here is kind of the same thing here. I've set my a to be 5, and I said that we know that 5 equals 3 plus 2. No argument there, right? Okay. Is it also true that 5 equals 4 plus 1? Yes. So if 5 is the same as both of these things, then those two things must also be equal. Right? That's kind of what we're saying here. You know, if n cubed over n cubed equals 1, but n cubed over n cubed is also equal to n to the 0 power, then those two things, n to the 0 power and 1, must be equal. Okay? And because n is a variable and can represent any value, that means that anything to the 0 power has to equal 1. Okay? If that is going too much for a kind of Friday, as long as you remember this, then you'll have success in this objective. Okay? But for those of you that care about why, this is the math behind it. All right? So going down to the practice here, it's only a one-page thing. There's not a whole lot to it, right? Simplify each expression. We already know that n to the 0 power equals what? 1. Right? We'll get to that in just a little bit. X to the 0 and y to the 0.
2.
Okay. What does x to the 0 equal? 1. What does y to the 0 equal? 1. What operation is happening? 1 times 1 equals 1. Okay. If we were adding x to 0 and y to 0, then it would be 2, right? Because it would be 1 plus 1, right? But since we're multiplying between our x and the y, multiplying between the bases there, 1 times 1 would equal 1. 3,481 to the 0 power. 1. Okay. 7y to the 0 power. Oh, well done, folks. Nicely done. Nicely done. The y to the 0 power, whoever's whistling can stop. Y to the 0 power equals 1. That 7, though, being a coefficient, thus not affected by the power, essentially what this is saying is 7 times 1, which gives us 7. Okay? So this is the only rule for which the coefficient stays the same. And the reason why is because that 0 power only affecting the base, there's nothing really for the coefficient to do. Okay? The y to the 0 equals the 1 because we're multiplying our coefficient 7 by that. 7 times 1 equals 7. Negative 9 to the 0 power. Negative 9. Again, this n to the 0 equals 1. We're multiplying that by our coefficient. So negative 9 times 1 gives us negative 9. Okay? When our expressions get a little bit longer and we have more stuff, like we have in that last one there, x cubed y to the 0 z squared, I have in the directions here, one thing that you can do is cross it out and ignore it. Because x cubed y to the 0 z squared, if we just kind of ignore the y to the 0, what are we left with? X cubed z squared. And that's our answer. Okay? (18n to the 0 z squared). We can just kind of eliminate this, just kind of ignore it, right? It doesn't factor in at all. What are we left with? 18z squared. Z squared. Okay? If you go into high school calling that 18z2, I'm really worried that you're not going to have anyone to sit with at lunch. Because that is like, I mean, just socially socially awkward, really, to say Z2. Luckily, I've got a year and change to fix that, but Z squared. Yeah, Max.
For like the negative t to the 0,
Yeah.
it'd be like -1.
Yeah. Negative t to 0 power. Max is saying, does this equal -1? Do we have agreements? Do we have? Think it equals 1? Okay. So really the question becomes, is that negative sign part of the base? Or is it a coefficient, right? Because if it's part of the base, then it's going to equal 1, because any base to 0 power equals 1. If it's a coefficient, then it's not going to change, and it would be a -1. What do you think? Is that negative sign part of the base, or is it the coefficient, Alex? And why do you say that? Bingo. If this were in parentheses, then it would equal 1, because it would include that negative sign as part of the base. Not being in parentheses, it is a -1. That negative sign is a coefficient. Okay, so -1 would be our answer. We did skip over one. Let's go back to it quick. We've got these 0 powers kind of in the expression. We can ignore them because it's basically saying that we don't have any there. It's as if, I also wrote a, b, c to the 0, d squared, e to the 0, f to the 0, g to the 0, h to the 0. I'm just telling you I don't have any of them there, right? It's kind of pointless to have them in there. That's why we can just ignore them. And we're left with a cubed, b to the 4th, d squared. Okay, d squared. Any questions that are popping up here? Yeah, Ren. Yeah. So last row, second one. We kind of saw this in CO11 also. We've got all this stuff in our numerator and all this stuff in the denominator of our fraction. So what we should do is simplify the numerator and the denominator separately, right? So simplify our numerator, we essentially end up with x to the 14th, y to the 5th. Right? We can't combine the base of y with the base of x. We have to keep them separate. They're different bases. So we have a total of 14 x's in our numerator and a total of 5 y's. In our denominator, we have a total of 14 x's and a total of 3 y's. Okay? So if we use the property of algebra and we say, well, what's going to happen with all 14 of my x's that are in my numerator and my denominator? They're all going to cancel out, right? Anything divided by itself equals 1. If we use our dividing by the same base rule, we'd subtract 14 and 14 and we end up with 0, right? Either way, they're gone. And so your final answer then would be y to the 5th over y cubed. Okay? Aiden.
Can you simplify it even more to be y to the 5th?
Oh, I'm sorry. Yes, you should. Silly me. My mind's already thinking about the weekend. Yeah. You should simplify further. 5 minus 3 would be y squared. Did you say y2? Oh, good boy. Okay, good. Yes, sir. What's that? Last row, fourth one. 1 over n to the 0. Who's got a thought of what this would simplify to be? Sophie? 1 over 1, right? That n to the 0 just becomes a 1, which then you'd simplify just to be 1. Okay? You've got like 11 minutes left. Let's pause the video and have you work through these other ones yourself, and then we'll come back and no homework for the weekend then. Okay? So we will pause. You work well, and that'll be that button. Okay, here we go. Back at the assignment, wrapping this up. 2 n to the 0, z to the 0 over 6. Who'd like to share what they got as a simplified expression? Jack? 1/3 is correct. Essentially, both of these bases just are not there. And so we end up with 2/6, which simplifies to be 1/3. Next one. What'd you get, Kylie? N to the 11th is correct. You can just eliminate the n to the 0. If you use the multiplying by the same base rule, which is what we have here, 4 plus 0 plus 7 is 11 anyway, right? But then just getting rid of that, we get 4 plus 7. X to the 5th or x to the 5th, Crinkle? 1. Yes. X to the 0, which equals 1. Negative 8 to the 0. Alex? Negative 1. Job well done. That 8 is a base, not a coefficient, so it becomes a 1. Negative sign out in front, which is not part of the base. Kind of the same thing as that negative t there. And lastly, 99 to the 0 power, Aiden, 1. Anyone have questions? Okay. You've got a math packet to work on. No homework for the weekend. That's all your math.